In this video, we're going to be looking at integration by substitution. So I have some examples to be solved here. But before we get started, we need to look at how integrals work. So we have to look at the general integrals and the result we are expected to get each time we carry out an integral. Here are just some of the examples that we're going to be using here. So the integral of a constant a is going to be equal to ax plus a constant c. So whenever you integrate a constant, this is what you are expected to get. Okay, then when you integrate x to the power of n, then this is what you're expected to get: x raised to power n plus 1 divided by n plus 1 plus the constant c, because these are indefinite integrals. So I'll take an example with this. For example, the integral of 2dx would be equal to 2x plus c. So 2 is a constant. Also with this, if I take x raised to power 3, so the integral of this is going to be x raised to power 3 plus 1 divided by 3 plus 1. That will be x raised to power 4 over 4 plus c. So when you integrate cos s, you're going to get sine x. And when you integrate sine s, you're going to get minus cos s. When you integrate the exponential, you get exponential back. Each time you integrate an exponential, you get your exponential back. So having said that, so we're going to apply these. These are just the basis. So they are the basis that we can use to carry out integration. So we're going to be applying all of this to carry out our integration as we move on. So let's quickly take, so the topic for today is integration by substitution. So let's get some examples to carry out these integrals. So I have a question 1 and 2 here. Question 1 says the integral of x plus 4 raised to power 5 dx. So we are using integration by substitution. So I'll start with the first part, question 1. So I have integral of x plus 4 raised to power 5 dx. So what I'll simply do is to substitute, use the u substitution. So I'm going to say u is equal to what is inside the bracket, x plus 4. So from here, my integral will look like this: integral of u dx. So what you have to do from here is to differentiate u with respect to s. So the u dx would be equal to, so when you differentiate this, you're going to get 1, and when you differentiate 4, which is a constant, you're going to get 0. So from here, you're going to make the s the subject of the formula. So from here, you can see that the s is equal to 1 times du. So in this part here, we're going to replace the s with du. So the integral becomes u. Okay, there's a 5 here, so we have to include that 5 du. So now you see we're integrating u with respect to u now. So this time when we integrate this, we're going to use apply the formula now. When you have x raised to power n, so this looks exactly as this. So this is going to be u raised to power 6 divided by 6, because I added 1 to this, and divided by 6 plus c. So you know from the beginning our u is x plus 4. So we can say that our final answer is going to be x plus 4 raised to power 6 divided by 6 plus c. So that gives the answer to this. So let's go to question 2. So for question 2, we have the integral of cos 3x plus 4 ds. So here we are using linear substitution. So what we're going to do, we're going to substitute u for 3x plus 4. Then we differentiate u with respect to s. So du dx is going to be equal to, so when you differentiate this, this is going to give us 3. And when you differentiate this, a constant, that's 0. So from here, if you make ds the subject of the formula, you find out that dx would be equal to du all over 3. So we're going to replace the s here with the u over 3. We're going to replace 3s plus 4 with u. So the whole integral becomes cos u times du over 3. So since this is a constant, you can just move it outward. That's this 3 here. So that becomes 1 over 3 integral of cos u du. Now remember, when you integrate cos u or cos s, you get sine s. So this is 1 over 3 times sine u plus c. So this becomes 1 over 3. U is 3s plus 4. So we're going to substitute that back. Sine 3x plus 4 plus c. So that gives the answer to the next part. So the next question 3, we have integral of 1 divided by 1 minus 2s ds. Again, we are going to use the u substitution again. So for question 3, I'm going to have integral of 1 over 1 minus 2x ds. So if I use the u substitution, my u is going to be equal to 1 minus 2x. Then I'll have to differentiate u with respect to x. So the u dx would be equal to, so when you differentiate, that's going to be this is a constant, so that's going to be 0. So when I differentiate minus 2s, that's going to give me minus 2. So I'm going to make the s the subject, because all I have to do is to substitute the whatever value I have for the s here. So if I move this up, I'll move this down. So I'm going to have du over minus 2 equals the s. So we can't keep the negative sign below. So the u would be equal to, minus du over 2 would be equal to the s. So the x is equal to this. So I'm going to substitute this for this. So this would now look like integral of 1 over 1 minus 2s is u. Okay. Then times minus du over 2. The minus and 2 are constant. So I'm going to move that outside. So that will look like minus 1 over 2 integral of the u all over u. Now, in the previous video, I omitted this. The integral of 1 over s is equal to ln s plus c. Ln s is the natural logarithm of x. So you can write it this way, or this ln s is ln s. So this way, either this way or this way. So so you can see that this looks like 1 over u du in terms of u. So this is going to be minus 1 over 2. Then the integral of 1 over u becomes ln u. That's the natural logarithm of u plus c. And we know what our u is. From our substitution, u is equal to what? 1 minus 2s. So this becomes minus 1 over 2 ln 1 minus 2s plus c. So that gives us the answer to this. Now let's take question 4. So for question 4, so this is a definite integral. So I will teach you how to work out definite integrals. So for definite integral, we have integral of 1 to 3, 9 plus x all squared dx. So this, again, we use our substitution. So u will be equal to 9 plus x. So when we substitute here, we are going to differentiate u with respect to s. So du dx would be equal to 1, because this is a constant, and when we differentiate it, that's 1. So we'll substitute now. We said that u is equal to 9 plus s. So what we are going to do, these values here are in terms of s. So we're going to get the values of in terms of u. So u1 would be equal to 1 here. That's 9 plus 1. That's 10. And u2 will be equal to 9 plus 3, which is equal to 12. So that means the integral now looks like 10 to 12 u squared. So we have obtained the u in terms of this. So from here you can see that dx will also be equal to what? Du. So you have to take note of all of this. So du. So this look like x squared du. So we just integrate this with respect to u. So this is going to be equal to, so when I integrate this, so this is a definite integral. So we integrate it separately from the one we have been doing by adding c, which is a constant. This time we're not going to add a constant. So this is going to be u, when you add 1 to the, that's 3 divided by 3, then from 10 to 12. So we just impute 12. So we are going to have 12 raised to power 3 divided by 3 minus 10 raised to power 3 minus divided by 3. So this would be 12 raised to power 3 is 1728 divided by 3 minus 10 raised to power 3 is 1000 divided by 3. And when you divide this by 3, that's going to give us 576 minus 1000 over 3. And when you work this out, this is going to give us 728 divided by 3. You can simplify this further if you so wish to. Now for question 5, integral of 2x into square root of 1 plus x squared dx. Now this type is very interesting, so you have to look at this. If you look at this value here, this x squared here, and look at this here, you will find out that when you differentiate this, you're going to have a power of x that is 1, which is the same as this. So once you can sense that each time you differentiate a higher power and you move down to the next lowest power that can even out the one outside, then you use the u substitution. So here I'm going to say u is equal to 1 plus x squared, and du dx is going to be equal to 2x, because this one is 0. So from here you can see that again I have to make du the subject. So from here dx rather is going to be equal to du all over 2x. So we're going to substitute u and du over 2x into this. So this will now become integral of 2x square root of u, because u is 1 plus 2x squared, times du over 2x. So from here you can see that this would cancel out this. So that's the essence. Once that cancels out that, we are left with integral of square root of u du. So all we have to do is to write this as fractional indices. So this is going to be u raised to power 1 over 2 du. Then apply the integral formula. So we're going to have 1 raised to power 2 plus 1 divided by 1 over 2 plus 1 plus the constant c. So once you start integrating, you put the constant c. So if you add this together, this is going to give us u raised to power 3 over 2 all over 3 over 2 plus c. And if you work this out, it's going to give you 2 u raised to power 3 over 2 all over 3 plus c. I hope you'll be able to work this out. It's very simple. What I did was u raised to power 3 over 2, and this one is a single fraction, divided by 3 over 2. So you change that to multiplication. That becomes u raised to power 3 over 2 times 2 over 3. So if you work this out, that gives you this. So let's go to number 5. For number 5, or question 5, wow, we have integral of 4x all over square root of 2x squared plus 1 dx, the same thing. So you see that the power of this is 2, the highest power of this is 2, and the power of this is 1. So you can see that when you use the u substitution and differentiate, the power of this becomes 1, and the power of this, which is the same as the power of this. So we use the u substitution on this. So u, so you can see where my substitution normally comes from the one with the highest power is equal to 2x squared plus 1, and du dx would be equal to 190 I'm going to have 4x, this is 0. So from here you can see that dx is going to be equal to du all over 4x. So let's substitute u and du over 4x for this and this. So this becomes integral of 4x all over square root of u times du over 4x. Again, this would cancel out this, meaning that we are going to be left with integral of du all over root u. So we'll just write this as, now this is not the same as 1 over x. It's not the same as 1 over root x. They are not the same. So you can't apply the natural, you can't take this to be the natural logarithm of root x. It is wrong. Okay, so you can't do that. So what you're going to do is this, you're going to rearrange this to become 1 over u raised to power 1 over 2. Again, we'll write it as fractional indices. So on writing this as fractional indices, you sense that this becomes integral of u raised to power minus 1 over 2 du. Okay, so I think we can now apply the integral formula now. So when we apply the integral formula, we are going to have this. So we're going to have u raised to power minus 1 over 2 u raised to power minus 1 over 2 plus 1 over minus 1 over 2 plus 1 plus c. It is an indefinite integral, so we have to add the c. So this becomes, so u raised to power minus 1 over 1 plus 2 is going to give us half. It's 1 over 2. Then this is also 1 over 2 plus c. So if you work this out again, you're going to have 2 u raised to power half plus c, and you know what our c, our u is. So our u is from our substitution, our u is 2x squared plus 1. So into 2x squared plus 1 raised to power half plus c. So this means square root. So you can rewrite it as this: 2 into the square root of 2x squared plus 1 plus c. So if you leave your answer like this, you are correct. If you leave it like this, you are also correct. So on to the last one. So here we have sine root x over root s. Some people just say we have root s here, let's just cancel it out. And no, you can't do that. So what we're going to do, we're going to use the u substitution again. What you're going to use the u substitution on is on the square root in s, because you have square root here. So you don't substitute to become s, u is equal to s, but the square root, to remove the square root. So you say let u equals root x. So if u equals root x, then this will be the same as x raised to power 1 over 2. You always learn how to write your roots in this format, so that you can easily simplify. So have du dx is equal to 1 over 2x. So we have 1 over 2 minus 1. So that's how to differentiate. I am sure that we are familiar with this. So when we differentiate this is going to give us du dx is going to be equal to 1 over 2 x raised to power minus 1 over 2, which is the same as 1 over 2 times 1 over x raised to power 1 over 2 fractional indices. So this becomes 1 over 2, 1 times 1, x raised to power 1 over 2. Okay. Next, so this is du over ds. So we have to get the value of du. So from here you can see ds rather in terms of du and this. So if you cross multiply, you will sense that I'm going to have 2x raised to the power 1 over 2 du is equal to ds. So we're going to use this to represent this here. Okay. And this is exactly the same as the root, this x raised to the power 1 over 2 is the same as 2 times the square root of x dx, du rather, which is equal to ds. So take note, this and this are the same. So if we go back to the integral, we're going to have sine. So instead of sine root s, our root s is the same as u all over 2 root x times 2 root x du, because I'm substituting this for the s here. So you see the essence is to cancel out this. If I decide to make this to be u, because we said that u is equal to root s, then this has to also be what? Root s is also u. So either way you go about it, you get the same result. So you see this will cancel out this. So we are left with the integral of sine u du, right? Okay. So we now integrate this. As we integrate, this becomes, when integrate sine u, that becomes minus cos u plus c. So that will equal to minus cos. Then our u is root x plus c. So that's the integral. So what you're going to do, you're going to pause the video and attempt these questions here. All right, see you in the comment section. If you really enjoyed this video, do not hesitate to subscribe, like, and comment, and also share the video. Bye bye.